If I'm
Yeah, I'll just.
yeah.
Is my screen visible?
Is coming up. Just yes, yes. Now it is visible. Yes,
Am I audible?
yes, clearly. Yeah.
Yeah,
You're not yet full screen though. Yeah.
yeah, I'm just. Yeah, is it clear
Yeah,
now?
yeah, it's very clear.
Yeah. Yeah, thanks the SKA team and doctor for giving this opportunity, and thanks Kiran for starting this presentation. So today I'll talk of from the facility point of view, what are the requirements that are expected while you set up the data center facility. So there are four tiers of data centers when we talk of. I mean, when I talk of tiers, it's basically referring to the Uptime Institute as they define it. The competing body is the Telecom Industry Association 942 standards. So people say tier one, tier two, tier three, tier four nowadays, but for the 942 standards, not much of talked about. The requirements are similar when I meet the tier requirements. So whether it's a 942 standard or a tier requirement, tier one, tier two, tier three, they call it as facility rated one, rated two, rated three, rated four. When you talk of the tier one, it's the basic data center. It has kind of 99.6% kind of uptime. There are no redundant components here. If something goes down, any of the components of the facility goes down, the data center is down. When I talk of tier two, we have again a single path, but we have some kind of redundant components kept as pairs within the facility, so it gives a slightly higher uptime. And then comes the tier 3 and tier 4. So tier 3 is concurrently maintainable. So I have two independent paths for every source, like could be cooling, could be power, which will power the IT part of the data center. So if one goes down, the other still maintains the continuity. So I can from a maintenance perspective, I can still take it offline to do maintenance and all. So it gives me kind of 99.98% of uptime. And then there's the tier 4, which we call as fault tolerant data center, which is kind of 99.995% uptime, which use it has two concurrently maintainable plus a third also, which can be used in case of requirement. So these are the four tiers or the 942 equivalent that we talk of when you talk of data center tiers. So depending on the SKA's requirements, which we talked of, like it was a tier 3 or something, so it can be decided that because again there is a cost as you go up the tier, it's not just into two or something, it's exponential. So depending on the requirements, so tier can be arrived at. And irrespective of the tier you invest in, so these are some of the data center ecosystem things that you need to understand. So we have the supply space as well as the demand space. So the supply space is what the data center facility will give, the physical data center, the data services that will be providing. And then the services from the demand side is from the associates, the astronomers, these research scientists, and their kind of service level expectations that they demand from the data center. So these are from a supply side or from a demand side. So while we design the data center, some of the things that we need to be looking at is uh, what kind of service level alignment am I looking at, what kind of ET factors that we talk of, the agility, the reliability, the flexibility, the availability, the resiliency that we need to build into the data center to make it available. What kind of standards that I need to be compliant to, what kind of regulations that any country specific regulations may not be applicable fully from a SK perspective, but from industry, some industries have some regulations that some data cannot be taken out of the country, some data needs to be kept within the country. So such kind of things that we need to look at. What are the risks, what are the challenges that needs to be looked at, what is the investment versus performance, or the kind of the capex versus opex, the capital expenditure versus operational expenditure, any specific local things that I need to be looking at, what kind of availability of personal availability, skill sets that are at a location. So these are some of the things that we look at. So the Sum total of this is the output strategy. So how do I balance the cost versus risk? How do I address growth? Because year on year, SKA will be growing in terms of compute, storage, and other parameters. So the real estate has to match as it grows. How do I give value to that? So consider cost to value. What kind of standards do I comply with? Regional versus central. Again, this is applicable more from an enterprise perspective because I have multiple data centers there. And then what kind of best industry practices that I need to look at, and how am I aligned to the IT goals in terms of what is expectations from the research community, and then what are the technology enablers from the IT side that we're looking at. So as we move ahead, so some of the questions that SK team would need to give thought to is that, what should be the tier certification classification? Should it be tier 2 or tier 3? Any specific uptime requirements that have been specified by the body? Will downtime lead to any monitor losses? If no, should SKA compromise from a tier 3 to a tier 2 facility because of the cost? I mean, there's some of the questions. You need not have the answers for that, but any guidelines specified? What are the timelines that you're looking at to go live? Because the higher the tier level, obviously the construction cost, the construction timeline goes up. Any specific requirement from an application behavior? As we heard Doctor in his earlier presentation that you'll be hiring the bandwidth, etc. But again, there'll be latency issues. So the application, how will it behave for some of the latencies that will come in? What are the recurring costs that we looked at? Total cost of ownership. There will be a trade-off between expense and performance. So is it okay? Again, one time versus recurring costs that we'll be looking at. What are the growth aspects? How much space will need on day one and possibly 10 years down the line as we expand? Some of the ET factors that I just talked of that needs to be looked at while designing data center. Do I need a DR again for this facility, or some of my counterparts in other countries facility will be my DR, kind of a reciprocal DR, what we call it as, or do I need to build a specific DR for my primary site here? So while designing that, what kind of power usage effectiveness that we should be aiming at? Because if you look at the running cost of a data center, 50% is power. From spending 1 rupee per year, 50 paise goes just into the power cost of it. So typically globally data centers, which have been, the enterprise data centers have PUEs, or some call it as DCIE, also data center infrastructure efficiency. It's about like somewhere around 2.2, 1.8, but nothing below 1.5 as such. So the higher the PUE, the worse the design. The lower the PUE, the very good is designs. So as Kiran talked of the multiple network that expected, so what kind of passive networks are expected? So while we design the passive, okay, so do I know that fiber? Do I look at copper, 100G, 400G, or the new upcoming, even the 1000G kind of support that are required? Different technologies that I'll be using. So these are some of the questions that needs to be answered before we embark on the design part of the data center. And just to conclude that some of the offerings that we provide on this, and the one in the blue box is what we bring to the table for SK. So any questions? And thank you for the time. We can take up, both Kiran and myself.
Okay, thanks. Is there any question about this now from the Zoom participants? Please raise your hand. Okay, I don't see any question for now. But of course we will be coming back to all this. If you still have any question, or if you want any clarification or point of discussion, we'll be coming back again at the end. So if there is no question right now, then maybe we will move to the next presentation in this session on AI and ML techniques in big data. So